All right, we're going to go ahead and finish up section C.1. And in this section, we're going to talk about polynomial functions and a concept called extrema. All right, so to start us off with, what are extrema? Well, if you think about living in extreme environments, it's exactly what it says. It's the worst, it's the best, it's the highest, it's the lowest. That's what we're talking about when we talk about extrema. And so extrema is a general term that we use when we are talking about the highest and lowest points, the extreme values on a graph. We have two types of extrema, and the first one, we already kind of know what this is, okay? Whenever we've been asked to find what's the maximum point or the minimum point, this is what we've been doing. But we do have a more specialized name for it. We call it an absolute, sometimes referred to as a global maximum or minimum. When we talk about absolute maximums or minimums, what we're referring to is the y-coordinate of the highest or lowest point for the entire graph. All right, so let's talk about a real life example. When we talk about the lowest point on Earth, this is kind of why we call it global sometimes, is the Marianas Trench in the Pacific. The highest point on Earth is Mount Everest. Okay, so globally, these are the highest and lowest points. We refer to them as absolute maximums and minimums. All right, so now let's go back to math, okay? And so the definition, our formal definition, is we say f of c is an absolute maximum if f of c is greater than or equal to all f of x, for all x in the domain. Similarly for absolute minimum. F of c is an absolute minimum if f of c is less than or equal to all f of x, or is less than f of x for all x in the domain. All right, so some things that I do want to kind of point out, and we're going to get into this later on in the next section. But if the degree of the function is odd, there will be no absolute maximum or minimum. If you think about a linear function with a slope, it goes forever down, it goes forever up. There is no absolute maximums or minimums. And this, we'll see, applies to all functions that have an odd degree. All right, if the degree is even, and the function has a domain of all real numbers, then the graph will have either an absolute maximum or minimum. And the key thing here is domain of all real numbers. If we're going forever to the left and forever to the right, we will have a lowest point or we will have a highest point, but we will not have both. Okay, so that is our first type of extrema, which is called absolute. The second type that we have is something called local or relative extrema. And the difference here is that a local relative maximum or minimum is the y-coordinate of the highest or lowest point in a particular area. So for instance, if we talk about this from our Earth perspective, the lowest point in North America is Badwater Basin in Death Valley, California. It is the lowest point in North America, but not in the world. The highest point in North America is Mount McKinley. Again, it's the highest point in North America, but not in the entire world. And you can do this for any spot on any area on the globe. I picked North America. But you can do this, you can even, restrict this further. If we talk about, the El Paso area, the El Paso Las Cruces area, the highest point is going to be at the top of the mountain, and the lowest point, could be down by the river. Okay? And so the important thing here is particular area, the area that we're looking at. Okay, so now let's talk about this mathematically. We say f of c is a local maximum if f of c is greater than or equal to f of x when x is near f of c. So if you're recalling the last video, we talked about, okay, we get to the top of a peak, we take our picture. These are going to be our local maximums. The other thing that we did is we also talked about hiking down the mountain. And when we got down to the bottom, we took a drink of water. And so that's what we're talking about when we talk about our local minimums, is the peaks and the valleys. They don't necessarily have to be the highest point on the graph, but once we hike up to the top of our mountain and then we have to go back down, we are at something called a local maximum. Same thing when we're down in a valley, or when we climb down to the bottom of a valley and then we turn around and go back up, we are at a local minimum. All right, so that's what we're going to be playing around with in this video. Okay, so now let's talk about a couple things that we do want to pay attention to. All right, the first thing that we have, and this is one of the ones that we do need to pay attention to, is local extrema cannot occur at endpoints. So for instance, if we do not have a domain of all real numbers, if this does not go forever left and forever right, then we do not have local extrema at those endpoints, whether they're included or not. Local extrema can only occur on open intervals. Okay, so what do I mean by that? In order for it to be a local extrema, you have to be able to go up one side and down the other, or vice versa. If you can only approach the number from one side, we do not classify it as a local maximum or minimum. All right, the second thing that we have is we want to be careful about what numbers are we going to plug in, because we're not going to be asking for maximum or minimum points. And so we're going to be asked one of two things. If we are asked what is the absolute or local maximum or minimum, you list only the x-coordinate. I'm sorry, the y-coordinate. Okay? When we talk about Mount Everest, why is it the absolute maximum? Because it's a height of whatever it is. That's the y-coordinate. On the other hand, if you were asked where is the absolute minimum or maximum, then you list only the x-coordinate. So Mount Everest is the highest point. And then we say, okay, well, where is it? Well, then we talk about where it is on Earth. Okay? Okay, now, a couple other things. We have absolute extrema, also local extrema, unless it is an endpoint. Okay? But local extrema are not necessarily absolute extrema. If you are the highest point for the entire function, you are also the highest point in the area. On the other hand, if you are the lowest point in the area, it does not necessarily mean that you are the lowest point for the entire function. So for instance, we talked about Death Valley being the lowest point in North America, but it's nowhere near as low as the Marianas Trench. The Marianas Trench is the lowest point on Earth, and if we are just in the Pacific Ocean, it's also the lowest point in that area. Now, in the last video, we reviewed positive and negative, and we talked about that we had to find x-intercepts to determine where the graph is positive and negative. Similarly, when we talk about extrema, we need to find where the extrema occur when we want to determine where the graph is increasing or decreasing. So we've already done the increasing and decreasing, and now we're just going to use those points to answer questions about what are the extrema, where do they occur, and what kind are they. All right, let's go ahead and jump into some examples and see how this works. All right, so let's go ahead and revisit our examples that we looked at in the previous video. All right, the first one we have is we have a graph that looks like this. And so the first thing we did last time is we did talk about increasing and decreasing. And so just a reminder that we had that our graph is increasing from negative infinity to -2. We reach the peak and then we turn back down. We turn back around and go down until we get to 2. And then we are increasing again. So when we talk about extrema, what we're looking at is we are looking at these points where we are transitioning between increasing and decreasing and vice versa. All right, so let's go ahead and I'm going to go ahead and start by identifying these points, and then we'll talk about what do we want to keep when we look at all the different stuff. All right, so the first point, let's go ahead and we know that x is -2. And I'm going to go ahead and say, let's let y be 5.2. It looks like it's a little bit higher than the halfway point. And remember that we do have our tick marks here are all increasing by 2. For the bottom one, we're going to say this is 2 and -5.2. All right, so now let's go ahead and see what we've got. All right, the first thing we're going to talk about is absolutes, okay? And so for this graph, we do not have absolutes here because it does go down forever and it goes up forever. We have no absolute maximums or minimums. So we're just going to go ahead and say none. Not applicable, okay, something along those lines. And similarly, we have the numbers at which the function has an absolute minimum or maximum. Same thing. not applicable, none, and we're done with our absolutes. On the other hand, we do have locals. And so remember that when we talk about what are refers to the y-coordinates. And so our y-coordinates is negative 5.2 and 5.2. So when we talk about the minimum, this is going to be negative 5.2. That is our local minimum. And our local maximum is positive 5.2. And so this is what we are looking at there. Okay, so again, when we talk about local, we're wanting to know, okay, how low does it go in the area? Or how high does it go in the area? And so, for instance, when we talk about this, again, just like when we talked about the Marianas Trench being the absolute lowest, on the other hand, if we restrict our map and we restrict it just down to the North America, then what we're basically doing is we're zooming in. And so, for instance, if I zoom in right here, well, I don't see anything else in the area, and so this is my local minimum. Same thing, if we zoom in over here, I don't see anything else, and so in this area, it is the local maximum. All right, so that is what are the local minimum and local maximum. The second thing we have is we want the numbers at which the function has a local maximum or minimum. And so remember, this is where is the local minimum or local maximum. And this refers to the x-coordinates. So we have a local minimum at 2. And we have a local maximum at negative 2. And we're done. All right, let's go ahead and look at some other examples just to kind of practice this a little bit more. All right, we have our next example. And again, let's talk about, last time we talked about increasing and decreasing. And so remember that we were decreasing from negative infinity to 3. We were increasing from negative 3 to 0. We decreased from 0 to 3. And we increased from 3 to positive infinity. Again, we want to go ahead and focus on these points where we are going from increasing to decreasing. And so the first one, I'm going to go ahead and call this negative 3. And I'm going to go with negative 5 on this one. Okay, it looks like it's pretty much in the middle. In the middle, we know what this one is. It's 0, 0. And then the one on the right, we're going to go ahead and call this 3, negative 5. Okay, so now let's go ahead and talk about our absolutes and our locals. Okay, so let's see here. We're going to start with our absolutes. Do we have any points that are the lowest points on the graph? And we do. And actually, we have 2. Okay, or we do have a absolute minimum. The lowest y value on our graph is negative 5. And it does occur at 2 locations. We're not going to worry so much about that. But here we have negative 5 We don't have any points lower than this, and so it is an absolute minimum. Now remember, for polynomial functions, we can only have either an absolute minimum or an absolute maximum, or none of the above. And so this one, we do not have an absolute maximum. We have that our graph goes forever up on both sides, and so that's it. All right, so since we don't have an absolute maximum, we don't have numbers at which an absolute maximum occurs. And so we can go ahead and mark that as not applicable as well. We want the numbers at which the function has an absolute minimum. And so we do have two here. It is going to be -3 and 3. And so remember that when we're saying where are the absolute maximums, the numbers at which the function has an absolute maximum or minimum, is we are looking at x coordinates. Okay, so now let's go ahead and talk about the locals. So remember, all of the points where we are going from red to green or green to red, these all are going to be locals, as well as some of them are absolutes, okay? All right, so let's talk about what are the local minimums and maximums. Okay, so remember, these are going to be the y coordinates again. And so we have local minimums at -5. We don't need to repeat it. We can go ahead and just write one of them. And we are going to add onto this, we have a local maximum. And so our local maximum is going to be up here. It is going to be a maximum of 0. Okay. All right. Remember, when we are asking what are they, we want the y coordinates. When we ask at what numbers, or at what the numbers at which the function has these values, that is, where does it occur? And so when we talk about our local minimums, it's going to be the same that it was last time for our absolute. It's still going to be -3 and 3. We also are going to add in our local maximum, and our local maximum occurs at 0. And so here, when we talk about what is it, we're looking at the y coordinate. When we talk about where is it, we are talking about the x coordinate. Again, when we talk about these points, we want to think about zooming in. And so, for instance, if I zoom in on my picture, we have a minimum right here. We're going down, we're going back up, and that is our minimum. It is going to be local, and we did see that it was global. If we come up here and we zoom in, we do have a local maximum. It's coming up, it's going down. If we zoom in just to this area, it is the maximum in the area. And same thing when we come down over here. If we look at just this area, we have that this point is a minimum. And so it is a local minimum. All right. We're going to try a couple more examples. We're going to revisit another one, and then we're going to look at a couple of new ones as well. Okay, so let's go ahead and try the next one. All right, this was one that we visited in the last slide. Again, we're going to go ahead and identify what we talked about before, and we talked about increasing and decreasing. So when we start on the left, we are increasing from negative infinity to negative 3. We reach the top, and then we decrease till we get to negative 1. We take our drink of water, and then we go up the mountain to 2. And we go a little bit down the mountain to 3, and then we continue hiking up to positive infinity. All right, so let's go ahead and identify these mins and maxes. All right, our first one we have is going to be here. And we're going to go ahead and say, okay, this is negative 3, comma, I'm going to say 16. Doesn't quite look like 15, so I'm going to go with 16, maybe a little bit bigger than that. And we're going with that because these tick marks on our y-axis are increasing by tens. And so I want a number between 10 and 20. It's a little bit closer to 20, but it's also kind of halfway, a little bit more than halfway between. All right, if we come down to this lowest point here, I'm going to call this negative 1, negative 10. It does look like it's on the tick mark there. My highest, I have a maximum over here. Okay, we're going up, and we are hiking up to about 2, and I'm going to put this at 18. It is, no, sorry, not 18. I'm going to go with 28. Okay, it looks like it's a little bit closer to that 30. And then we have our point right here. I'm going to call this 3, and I'm going to call it 24. Okay. Again, these are estimates. Okay. And you're not going to be marked off if you're, one digit off from me. Okay. All right. So now let's go ahead and see what we can do. All right. The first thing we want to know is, do we have any absolutes? And again, for this one, we don't. Okay. We don't have we don't have an absolute minimum. We don't have an absolute maximum. We don't have numbers where these occur. And we don't have this because we are going down forever and we are going up forever. So we never reach a lowest point or a highest point. Okay, the next thing we want to know is we want to know what are the local minimums and maximums. And so remember that when we talk about what are they, our local minimums are going to be the y-coordinates. And so I have this negative 10 here. This is where we're going down and then turning around and going back up. It's a minimum. We also have one over here. The same thing. We're going down and then we go back up. And that's our definition for minimums, local minimums. And so we have local minimums at negative 10 and 24. All right, the numbers at which the function has a local minimum, this is going to be our x-coordinates. And so these occur at negative 1 and 3. All right. That takes care of our local minimums. Okay, the next thing we want is we want our local maximums. And so again, a local maximum is we're going up and then turning around and going back down. And so when we want to know what are they, we have a local maximum of 16, and we also have a local maximum of 28. When we want to know the numbers at which the function has a local maximum, we want our x-coordinates. And so we are going to go -3 and 2. And we're done. Okay, we're going to look at 2 more examples, and the main thing that we're going to focus on now is we're going to take away this restriction of a domain of all real numbers. And so the next couple examples are going to have endpoints. All right, the next 2 examples that we are going to look at are going to be examples where we don't have a domain of all real numbers, meaning that we're just going to be looking at a closed interval. Okay, we're only going to be looking at part of a polynomial function. Okay, so the main difference to remember here is that if we have endpoints, which we do, and they are minimums or maximums, they cannot be local. Remember that local mins and maxes, you have to be going up on one side and down the other, or vice versa. They can be absolutes, and so because it is technically the highest point on the graph or the lowest point on the graph, it is still an absolute maximum or minimum. Okay, so let's go ahead and look at this first example. Remember, when we say what is, we want the y-coordinates, and we say where are they, then we want the x-coordinates. So let's go ahead and look at our graph and see what we have. All right, we want to start by finding an absolute minimum. Do we have a lowest point on the graph? And we do. We have one right here. And let's go ahead and call this 0.5, comma, and I'm going to say -3.2. It does go a little bit lower than -3. And so when we say what is the absolute minimum, it's the y-coordinates, so it's going to be -3.2. When we say where is the absolute minimum, it's going to be at 0.5. All right, do we have an absolute maximum? And we do. We have a highest point over here on the left. This point is -2, 3. And so we have an absolute maximum, which is our y-coordinate is 3. Where is it? This occurs when x is -2. All right, the next thing we want is local minimums or maximums. And for this graph, we do have a local minimum, and our local minimum is going to be here on the bottom. This is local as well. It's the lowest point in the area, and it also satisfies the condition that we are decreasing on one side and we are increasing on the other side. And so we have a local minimum of -3.2, and it occurs at 0.5. We do not have any local maximums. And remember that the reason that it does not qualify, that either of these two endpoints do not qualify as local maximums, is because we don't have increasing and decreasing on either side. And so this is going to be not applicable, or none. Okay, the only point that we have increasing on one side and decreasing on the other is that local minimum. All right, let's try another example. Okay, if we look at our next example, we have kind of the same idea here. We do have an absolute minimum, and our absolute minimum is going to be right here. Because our tick marks are increasing by 2, I'm going to call this 1, -2. Our absolute minimum is going to be the y-coordinate, so it's going to be -2. It occurs at 1, and we have that one. Okay, so then we come to the question of, do we have an absolute maximum? And the answer is no. And this is no because even though we have a highest point here, this is a ghost point. It's an open circle. You are not allowed to plug in 4 into our domain. 4 is not in the domain, and so we can't even say, okay, it's 3.9999999, because, well, there's always one more 9 we could add on to it that would be bigger. And so if ever we have that these highest points or these lowest points are open circles, then they don't qualify as absolute maximums or minimums. So we're going to go ahead and say not applicable for absolute max, and we don't have a location where we have an absolute maximum. Our local minimum, because we do have decreasing on one side, increasing on the other, this does qualify as a local minimum. And so we have a local minimum of -2 at 1. And again, we do not have any local maximums, even though we do have a highest point here in the area on the left. It doesn't qualify because we don't have an increasing and decreasing on either side. And same thing, we have a ghost point up here, and so it doesn't qualify either. All right. The last thing that we're going to do is we're going to sketch a graph that has some conditions that we want to meet. Now, when we talk about these sketches, there are lots of different ways that we can go ahead and sketch these. Everybody's picture is going to be different. All right, the first thing that we have is, let's figure out what points do we have here. Our first point is we are going to have an absolute minimum of -3 at x equals -2. So that is going to be one point that we want on our graph. X is -2, y is going to be -3, and this is an absolute minimum. We also want a local minimum of -1 at x equals 2. And so this is going to be 2, -1, and it is a local min. Okay, so now when we graph this, we have -2, -3. And because it is an absolute minimum, I know that everything else has to be above it. So this is not going to extend down forever. And we also have a local minimum at -1, at 2, -1. Okay, so when we graph this, in order for this to be the absolute minimum, we need it to be coming down as we approach this point, and then it needs to turn around and go back up. Because we have a local minimum, same thing, we need to go down to approach it, and then go back up. And so this would be an example of a graph that we could have. All right, let's go ahead and try another example. We want to sketch a graph of a continuous function, and we are told no absolute extrema. And so what that means is, remember that we don't have absolute maxes or mins if it goes down forever on one side and if it goes forever up on the other side. But we do have a local minimum of -2 at x equals -1. So we are going to have a point of -1, -2. And we are also told that we have a local maximum at 2, 1. I'm sorry, 1, 2. All right, so if we go ahead and plot these 2 points, we have -1, -2. We have a point of 1, 2. Okay, and remember this is a local min, and this is a local max. Okay, so in order to be our local minimum, that means I need to be going down and then back up. In order to be a local maximum, we need to be going up and then back down. And so this is a sketch of our graph. All right, that finishes off section C.1. In the next section, we're going to go ahead and talk about some other things that happen with polynomial functions or functions in general. The next thing we're going to talk about is symmetry. I will see you guys again soon.